Our planet seems serene from a distance, a tranquil blue marble swirled with white clouds floating in the vast silent darkness of space. But you know, this calm exterior conceals a violent and chaotic past. Earth wears the hidden scars of countless cosmic collisions. These are not mere dents or scratches. They are profound wounds, testimonials to a time when the heavens fell upon us. Buried beneath our oceans, hidden by dense forests, and eroded by the patient work of wind and water, are the ghosts of ancient impacts. These colossal craters tell a story, a dramatic saga of creation and destruction, a history written in stone and fire, stretching back billions of years into the infancy of our solar system. To uncover this story, we must become detectives of deep time. We must peel back the layers of geology and life that have grown over these ancient wounds. Imagine a cosmic hailstorm that raged for eons. Our young Earth was a target in a celestial shooting gallery. Asteroids and comets, leftovers from the formation of the planets, careened through the void. Each impact was an event of unimaginable power, an explosion that dwarfed all of our nuclear arsenals combined. The evidence of this tumultuous youth is all around us, if we only know where and how to look. The surface of our world is a dynamic canvas, constantly repainting itself. Plate tectonics shifts the continents, volcanoes pave over the land with fresh lava, and erosion grinds mountains down to sand. This is why Earth, unlike the Moon or Mercury, doesn't look pockmarked. Its face is constantly getting a geological facelift. But the scars are still there. Some are so vast they are only recognizable from orbit, their circular patterns spanning hundreds of kilometers. So, let us embark on a journey. A journey not across space but through time. We will travel back millions, even billions of years. We will visit the sites of the most powerful impacts our world has ever endured. What exactly is an impact crater? It is more than just a hole. It is a scar, a definitive wound left by a high-velocity collision with an object from space. Think of it as a cosmic fingerprint. When an asteroid or comet, traveling at tens of thousands of kilometers per hour, strikes a planet, it doesn't just dig a hole. It releases an almost incomprehensible amount of energy in an instant. This energy is so immense that the solid rock of the impactor and the target surface behave like liquid. They vaporize, melt, and splash outwards in a cataclysmic explosion that is both beautiful and terrifying in its power. The formation of a giant crater is a process of moments, but its consequences last for eternity. First comes the contact and compression. The impactor penetrates the surface, transferring its kinetic energy into the ground as a powerful shock wave. This shock wave travels faster than the speed of sound, shattering and vaporizing rock in its path. Then comes the excavation stage. A massive transient cavity is blasted open, throwing molten and pulverized rock, called ejecta, for hundreds or even thousands of kilometers. But the violence isn't over. The initial deep bowl is unstable. Gravity immediately goes to work. The steep walls of this transient crater collapse inward. In the very largest impacts, the rock in the center, compressed by the initial shock, rebounds upwards. It behaves like a slow-motion droplet in a pond, creating a central peak or a ring of mountains inside the larger crater basin. This entire process, from the first touch to the final form, can take just a few minutes, yet it permanently alters the geology of a region, leaving a telltale structure of shattered rock, uplifted cores, and melted minerals that can endure for billions of years. So when we search for these giant craters, we are not looking for simple bowls in the ground, we are searching for these complex signatures. We look for circular patterns in the landscape, rings of hills and central uplifts. Geologists search for specific clues: shocked quartz, a type of mineral whose crystal structure is fractured in a unique way that only an impact can produce. They look for shatter cones, distinctively patterned rocks that point back to the center of the explosion. These features are the smoking guns of a cosmic collision, the undeniable proof that the sky once fell. Our first stop takes us to South Africa. Here we find the planet's largest and oldest confirmed impact structure. It is called the Vredefort Dome. This is not a crater you can stand on the edge of and look into. It is far too big and far too old. The original crater, estimated to have been a staggering 300 kilometers across, has long since eroded away. What we see today is its deep, fossilized root, a multi-ringed structure that reveals the profound violence of its birth. The impact occurred an almost unimaginable 2 billion years ago. At that time, life on Earth consisted of only single-celled organisms floating in the ancient seas. The discovery of Vredefort as an impact structure was a long and winding scientific journey. For decades, geologists were baffled by the strange circular arrangement of hills near the town of Vredefort. They proposed various theories, with many believing it was the result of a massive volcanic explosion. It wasn't until the 1990s, with the discovery of shocked quartz and shatter cones, those telltale signs of an extraterrestrial impact, that the scientific community reached a consensus. The evidence was undeniable. This was the site of a collision with an asteroid estimated to be 10 to 15 kilometers in diameter, a mountain-sized rock from space. Imagine the scene 2 billion years ago. An object larger than the one that would later kill the dinosaurs slammed into the Earth. The energy released would have been hundreds of times greater than the Chicxulub impact. It would have vaporized the ground, created a temporary crater deeper than the Mariana Trench, and sent shock waves rippling through the planet's crust. For a time, the very atmosphere would have been a furnace, and the seas would have boiled. It is possible this colossal event altered the global climate and may have even influenced the evolutionary path of the simple life forms that existed at the time. Today, the Vredefort Dome is a UNESCO World Heritage Site, a natural laboratory for studying the mechanics of giant impacts. The Vaal River flows through the center of the structure, carving a beautiful landscape out of this scene of ancient devastation. As you drive through the rolling hills of the dome, you are traveling over the uplifted core of the crater. You are, in a very real sense, exploring the anatomy of a scar that is almost half as old as the Earth itself. It's a humbling reminder of our planet's long and violent history, a history that began long before we ever arrived. Now we journey forward in time from 2 billion years ago to a mere 66 million years ago. We travel to the Yucatan Peninsula in Mexico. Here, half buried beneath the limestone platform and half submerged under the Gulf of Mexico, lies a crater with a far more famous story. This is Chicxulub, the impact site that marks the end of an era. This is the place where the world of the dinosaurs came to a fiery, dramatic end. The crater, about 180 kilometers in diameter, was created by an asteroid or comet roughly 10 kilometers wide. It struck the Earth with the force of billions of atomic bombs. For decades, the idea that an impact killed the dinosaurs was a fringe theory, proposed by the father-son team of Luis and Walter Alvarez in 1980. They had discovered a thin layer of iridium, an element rare on Earth but common in asteroids, in rock layers all around the world, dating to precisely the time the dinosaurs vanished. They argued this was the fallout from a massive impact. But where was the crater? The search was on. The breakthrough came in the early 1990s when geophysicists, reviewing old data from a state-owned oil company, noticed a huge semicircular gravitational anomaly centered near the port town of Chicxulub Pueblo. The impact itself was an apocalypse. The asteroid slammed into a shallow sea, vaporizing the water, the asteroid, and a huge chunk of the Earth's crust in a fraction of a second. This unleashed a cascade of global catastrophes. A megatsunami, perhaps kilometers high, raced outwards from the impact site, inundating coastlines around the globe. Trillions of tons of superheated rock and dust were blasted into the atmosphere, which then rained back down, heating the air to oven-like temperatures and igniting global wildfires. The world was plunged into a nightmare of fire and flood, but the worst was yet to come. The fine dust and sulfur-rich aerosols from the vaporized rock lingered in the stratosphere for years, perhaps even decades. They created an impact winter, blocking out the sun's light and warmth. Photosynthesis on land and in the oceans shut down. The food chain collapsed, starting with the plants and ending with the mighty dinosaurs. Over 75% of all species on Earth went extinct. It was one of the most significant extinction events in our planet's history, a stark reminder that what the cosmos gives, the cosmos can also take away. Our cosmic tour now takes us to Ontario, Canada, to a place that shows how destruction can lead to a strange kind of creation. Here we find the Sudbury Basin. This is the second largest impact structure on Earth and one of the oldest, at about 1.85 billion years old. The original crater is thought to have been around 250 kilometers across, a vast wound on the ancient North American continent. Like Vredefort, the Sudbury Basin has been deeply eroded and deformed over geological time, leaving behind an elliptical structure about 62 kilometers long and 30 kilometers wide. It's a geological wonderland born from an astronomical event. The Sudbury impact was truly immense. A comet or asteroid, estimated to be about 10 to 15 kilometers in diameter, smashed into the Earth. The collision was so powerful that it didn't just shatter the crust, it melted it. The impact created a gigantic sheet of superheated magma, a temporary lake of molten rock larger than any volcanic eruption in Earth's history. This colossal melt sheet is the key to Sudbury's modern identity. As this lake of magma slowly cooled over thousands of years, something amazing happened. Heavy, metal-rich minerals began to settle out and concentrate at the bottom of the basin. These concentrated minerals are the reason Sudbury is world-famous today. The impact inadvertently created one of the richest mining districts on the planet. The basin is a treasure trove of nickel, copper, platinum, palladium, and other valuable metals. The very elements forged in the hearts of distant, long-dead stars were delivered to Earth by a cosmic impactor, then concentrated by the unique geology of the crater it formed. The city of Sudbury's economy and history are inextricably linked to this ancient cosmic catastrophe. The wealth of a nation was literally delivered from the heavens. This connection between a celestial impact and terrestrial riches is a profound one. It illustrates the intricate and often surprising ways that events in space can directly shape human society and history. The people of Sudbury go about their daily lives inside a giant, ancient impact crater, their prosperity drawn from the remnants of a cataclysm that occurred billions of years before the first human walked the Earth. The Sudbury Basin is a powerful monument to the idea that even in the most violent acts of cosmic destruction, there can be seeds of unforeseen opportunity and fortune. Let us fly north, to the remote wilderness of Quebec, Canada. From space, a spectacular feature dominates the landscape, a giant water-filled ring. This is the Manicouagan Reservoir, and it traces the inner ring of one of the largest and best-preserved impact craters on Earth. Known as the Eye of Quebec, the Manicouagan crater is about 100 kilometers in diameter, though the original transient crater was likely smaller. The prominent 70-kilometer ring we see today is an annular lake that fills a trough created by the impact's shockwaves surrounding an uplifted central island known as René-Levasseur Island. It is a breathtaking sight. The impact that formed Manicouagan occurred about 214 million years ago, during the late Triassic period. This was a time before the Atlantic Ocean had fully formed, when dinosaurs were just beginning their long reign. An asteroid, probably about 5 kilometers in diameter, screamed through the atmosphere and slammed into the ancient continent. The impact created a complex crater structure with the central part of the crust rebounding to form the island we see today. Over millions of years, glaciers and erosions sculpted the landscape, but the crater's fundamental ring shape remained remarkably clear, a perfect circle visible from space. An intriguing, though now largely debated theory once linked Manicouagan to a mass extinction event. Scientists noticed that several large impact craters, including Manicouagan in Canada, St. Martin in Manitoba, and Rochechouart in France, all seem to have a similar age. This led to the multiple impact hypothesis, the idea that a fragmented asteroid or comet struck the Earth in a chain, like the Shoemaker-Levy 9 comet that hit Jupiter in 1994. The theory proposed that this string of impacts caused the Triassic-Jurassic extinction event. However, more precise dating has shown the impacts were likely millions of years apart, not simultaneous. Even without a direct link to a mass extinction, Manicouagan is of immense value to science. Because it is so well preserved, it serves as a textbook example of a complex impact crater. Geologists can study its central uplift, its melt sheet, and the shocked rocks to better understand the physics of these colossal events. The reservoir itself, created in the 1960s by the Daniel Johnson Dam, has made the crater's form even more striking. It stands as a silent, beautiful monument to a moment of unimaginable violence, a cosmic bullseye etched into the Canadian Shield for all time. These giant craters are more than just geological curiosities. They are agents of change. Their formation represents moments of profound and abrupt transformation for our planet and the life upon it. The Chicxulub impact is the most dramatic example. It didn't just end the age of reptiles, it cleared the way for the age of mammals. In the shadow of the dinosaurs' extinction, our small, shrew-like mammalian ancestors found new opportunities. They survived the apocalypse and diversified into the ecological niches left vacant. Without that asteroid, you and I would almost certainly not be here. Our very existence is an echo of that impact. The influence of these events extends deep into the fabric of our planet. The Sudbury impact shows how collisions can create incredible concentrations of mineral wealth, shaping economies and industries billions of years later. Other impacts may have had even more fundamental effects. Some scientists hypothesize that the immense heat and pressure from early giant impacts during the Hadean Eon, the hellish first 500 million years of Earth's history, could have created hydrothermal systems. These systems, rich in chemical energy, might have been the perfect incubators for the very first life on Earth, the crucibles where chemistry became biology. Impacts can also be architects of landscapes. Craters can create basins that later fill with water, forming lakes that support unique ecosystems, like Lake Manicouagan. The shattered rock within and around craters can be more susceptible to erosion, influencing the paths of rivers and the shapes of valleys for millions of years. The immense energy of an impact can trigger massive volcanic activity, releasing gases that alter the atmosphere and climate. The story of Earth's geology and geography is punctuated by these violent interruptions from the cosmos, each one leaving an indelible mark on the planet's surface and its future. Even the history of science itself has been shaped by the study of craters. The debate over their origin, volcanic versus impact, forced us to accept a more dynamic and less isolated view of our planet. It connected the fields of astronomy and geology in a profound way. The discovery of the Chicxulub crater and its link to the dinosaur extinction was a triumph of the scientific method, involving multiple disciplines from paleontology to nuclear physics. The study of craters has taught us that to understand the history of life on Earth, we must also understand our planet's place in the wider and sometimes violent cosmos. So what do these giant craters tell us? They tell us that we live on a planet with a dramatic and violent past. They remind us that the Earth is not an isolated sanctuary, but an active participant in the life of the solar system. For billions of years, our world has been a target in a cosmic shooting gallery, and the evidence is written in its crust. These impacts are not just random acts of destruction. They are a fundamental part of our planet's story, driving geological processes, creating economic resources, and redirecting the very course of evolution. They are woven into the fabric of our world. The story of craters is also a story of perspective. For most of human history, we were unaware of this hidden past. We saw the Earth as a stable, predictable stage for our lives, but science has pulled back the curtain, revealing a much grander and more dynamic reality. The discovery of these impact structures has fundamentally changed our understanding of Earth's history and the forces that have shaped it. It connects us to the cosmos, reminding us that the sky above is not just a beautiful backdrop, but an active environment that has and will interact with our world in profound ways. This knowledge brings with it a certain humility and also a responsibility. We now know that events like the one at Chicxulub are not just a thing of the past. Asteroids and comets still cross Earth's orbit. While giant impacts are rare, they are not impossible. This realization has spurred us to action, giving rise to programs that scan the skies, cataloging near-Earth objects and assessing potential threats. For the first time in the 4.5 billion-year history of our planet, one of its species, us, has the awareness and the capability to potentially defend itself from this kind of cosmic danger. Ultimately, the giant craters of Earth are more than just scars. They are portals to deep time. They are lessons written in stone. They teach us about the fragility of life and the immense resilience of our planet. They show us that our existence is the result of a long chain of cosmic and terrestrial events, a delicate balance of chance and necessity. When we look up at the night sky, we should do so with a sense of wonder, but also with the knowledge that we are part of that vast, dynamic, and sometimes